My name is Massimo Banzi and I'm one of the co-founders of the Arduino project. And we're here for another video about our Arduino starter kit. Today we're going to look at the new project called the touch sensor lamp. This is a simple circuit where we're going to build a sensor that is able to detect when a human being is touching the circuit. You can see that if I touch this wire, the LED turns on. For this tutorial, we're going to introduce a new concept from the Arduino platform, external libraries. This is a very powerful concept because there are some things in Arduino programming that are very complex for a beginner. Like, for example, in this case, we are building a touch sensor. The touch sensor uses a fairly complex process for a beginner, and it would be quite complex for a beginner to write the code completely by themselves. So somebody with a lot of skills in Arduino programming developed a library that is able to perform this sensing function. On the Arduino website, you're going to find all the instructions you need in order to install a new library into the Arduino development environment. But let's have a look at this circuit. Here, we have an LED connected to pin number 12 of the Arduino. And then we have this strange circuit where we have a resistor connected between pin 2 and 4 of our Arduino. And then there's a wire connected to pin number 2. If I touch the wire with my finger, the LED turns on. So this is due to the capacitive sensor implemented by the library that we are going to see in a few seconds. The capacitive sensor is able to detect when a human being is touching a metallic surface. It's the same principle used by the touch sensor on the screen of every iPhone or Android mobile phones that you might have used. We can also increase the sensitivity of the sensor by using an external metallic surface. So I'm going to use a piece of printed circuit board that hasn't been etched yet. So as you can see, it is a piece of fiberglass with some copper on top. So we're going to connect this to my circuit and see what happens if I place a bigger surface. So we're going to help ourselves using this alligator clip. I'm going to connect the alligator clip to the wire and then to the copper surface. So now when my hand touches the surface, it turns on and off. Actually, what happens is that I don't even actually have to touch the surface. It starts to sense my hand even when the hand is just closed. Actually, if we flip the board around, here we have an insulating surface made of fiberglass, and still, if I place my full hand on it, it can still detect my hand. So the capacitive sensor is very useful because I can actually detect the touch of a person even through certain insulating materials. Now let's have a look at the code. Here you can see something new already at the beginning of the code. We are using this statement called include. You have this pound sign followed by include and capsense.h. So this statement tells Arduino to look for a library called capsense and include that into our program. As I said before, this is quite useful because it's going to introduce a piece of code which is quite complex and is going to make your life very simple. And you can find online literally hundreds of libraries that encapsulate the functionality of very complex sensors and provide you a very simple way to use them. So they are an incredibly powerful part of the Arduino platform. So a little further down in the code, you can see that we are creating an object of type capsense, and this object is called capsensor, and we are specifying that pin 4 and 2 are the two pins connected to the resistor, and pin number 2 is actually the one that goes to the sensor. So later on, we create another variable called threshold that is set to value 1000. This value will need to be determined experimentally while you work on your code. And finally, we create a constant called LED pin that specifies that the LED is connected to pin number 12. In the setup, you'll see there's nothing complex. There's a serial.begin that opens a communication channel with the computer at 9600 bits per second followed by a pin mode LED pin output that makes sure that the pin connected to the LED is set as an output so that we can turn it on and off. If we look at the setup, we can see that there is an interesting command here. We're using the CapSense library to read from the sensor, and the number 30 between brackets here is indicating that we want to read 30 samples from the sensor. This makes sure that we filter out any unwanted noise or false reading. The value read by the sensor goes into this variable called sensor value. Later on, we print sensor value towards the computer so we can visualize it with a serial monitor. After that comes the moment where we have to actually decide if the LED has to be on or off. If sensor value is